Hello, good afternoon to everyone. Welcome to the virtual Fireside Chat series with GeoWorks, titled GeoInnovation in the Built Environment. Well, today we're going to be joined with three panelists. Professor Kee Po Lam, Provost, Chair Professor of Architecture and Building, Dean, School of Design and Environment from the National University of Singapore. Welcome, Professor Kee.
Hello.
We have with us also Mr. Leslie Wong, the Managing Director of ESRI South Asia. Hi, Leslie.
Hi.
And finally, we have Mr. Saibal Chowdhury. He's the co-founder of Urban Ethic.
Hello everyone. Pleased to be here.
Great. So today's growing populations, mass urbanization, and climate change are creating enormous challenges for the world's infrastructure. In fact, it is estimated that by 2050, 68% of the world's population will be living in cities and will need an estimated 1,000 new structures a year just to keep up. In recent years, there has been a growing trend towards enabling greater synergy between CAD, GIS, and BIM by bridging the gap between traditional planning and design silos. So probably just to kick off this discussion, we have a question. What can you say about the built environment industry in Singapore? Anyone would like to kickstart this discussion?
Well, okay, maybe I can get the ball going. Once again, very good to see you, Prof. Lam and Saibal, and welcome everybody. Thank you for tuning in. So I guess reflecting on the question, I think in Singapore here, we live in a very land-constrained area. So we've had a lot of creative thinkers and planners create spaces and places and networks or infrastructure. And I think they're quite good at it. But I also think they'll be among the first to say there are more ways to do it better. I don't speak from their level of expertise, like Prof. Lam, who grooms a generation of these kinds of thinkers. But I speak from a position where I've got the benefit to support lots and lots of users of our technology. So I think what we've observed, what we've heard from our user base is in the urban built environment sector, there are largely 4 stages. There's a planning and design, then there's this construction, and then there's a maintenance and operations, and then the community engagement. It's a life cycle. Some assets have longer life cycles than others. Prof. Lam is nodding because I learned this from him too. Now, among these 4 life cycles, typically people specialize in just 1, maybe 2. Very seldom do they span the entire 4 stages, except maybe with the exception in Singapore of JTC. But even then, not all of the divisions touch all 4 stages. So knowledge, from one stage or the planning stage goes to the construction stage. Sometimes some information elements tend to kind of get lost in the transition. Not the legal aspects of it, okay? But what I mean is some types of information that may have been thought to be nice to have, but actually became later on discovered actually very necessary and very useful. So I think we've observed a lot of these kind of things happening, from knowledge from one stage to another stage being a little bit lost. And I believe that all the players in all these 4 stages do have a general desire to want to be able to be more effective and efficient in taking over and passing on the asset in the different life cycles to the next stage.
Okay. Well, if I can follow up on Leslie's point, great points that's been made. I think one of the sort of awareness that all of us should sort of reflect on is really our relationship to the built environment. It's something that I suppose we all take for granted because we live, work, play in it. We eat, sleep in it, and we just take it all for granted that it is there, right? and therefore the assumption that somebody somewhere somehow will take care of everything of the environment, and that is really far from the truth. It is really a collective endeavor to create a built environment that supports the live, work, and play. It's everybody's effort. It's not just the planners, the designers. It's the occupants. Is equally important in that process. And I think the COVID has taught us many, many lessons. How important it is to have the holistic approach to the built environment, and not just think of it as an industry per se. And moving forward to capture what are some of the quantifiable challenges. Really, to me, the Singapore Green Plan really captured many of those elements very well. That the built environment really directly or indirectly impact and contribute to most of those pillars, right? City in nature, sustainable living, energy reset, green economy, resilient future, and even green government. I think those pillars all have a direct connection to the built environment. And therefore, the quantitative kind of objective that are being sort of shared through those pillars are something that I think the GIS movement and the IT movement can really address and support moving forward. Thank you.
Thank you, Prof. And thank you, Leslie. I have the advantage of speaking the last. So I will touch upon something different. As an outsider, we're not born in Singapore. The perception of Singapore outside the world is it's a massive concrete jungle, right? That's what people perceive, right? But actually, when you come here and you stand up on top of a rooftop of a 15-story building, you can actually see the whole Singapore almost, right? And then today, the built environment is only 34% of the Singapore total land. And if I say that if we think that God has given you the whole land from a national development perspective, I would like to know how to take the minimum of the land and maximize the space. Space means a sense of space. That's very important from the design perspective. And that makes Singapore very special, where only taking 34% of the total land mass, and we are still creating a space and taking the space, and we are actually creating a livable city. And that, to me, is a revelation, basically. How do we do it, right? So that's one part. If you look at the total mass, it's around 727 basically square kilometer, right? And if you look at from that perspective, and 34% is all taken up, and if you calculate average, let's say 8 or 9 plot ratio or FAR, you could actually see how much GFA. And then if you take an average standard that 20 square meter a person needs in life to basically, when a child is born, he deserves that much space, right? So how do we manage it? And that's because of technology. If you look at the productivity point of view, the average productivity, the global construction industry is 1% or less than 1% for the last 20 years. Singapore has improved up to 33% productivity. And that tells a lot. It's because of infusion of technology into the built environment. And that's basic. And the labor productivity is also probably one of the highest in Singapore compared to the world average. So to me, when I look at our relationship with the built environment, we probably have been relatively more successful than the rest of the world in maximizing and optimizing the land that we have. And then, as Leslie put in, because we bought in a landlocked society, we are more innovative and we keep thinking about it. So that's what basically my perspective with it. In fact, yeah, I still think that it is far more, for the similar countries, we feel a more sense of space, even in a small space. Yeah.
Thanks, Saibal. Interesting insight from an outsider.
If I could respond also very briefly to Prof. Lam and Saibal's sharing. Yeah, I think Saibal, you're right. When we face constraints, somehow we're forced to be more innovative. And we've got to find opportunities. And meanwhile, as our generations mature and evolve in Singapore, not just us, but any other mega city, with more and more planning happens in brownfield sites. So Prof talked about green, but actually I know he totally understands, you know, brownfield kind of situations as well. So we have sometimes it's greenfield, but very, very few. It mostly is brownfield, and different people have different desires from the neighborhood, from the environment. But how do we sort of like get everyone on the same page to agree collectively? I think here in the built environment sector here, I think that's where, you know, digital twins. That's why there's so much interest in digital twins. If we talk, especially if there's a generation gap, sometimes it's very hard, very challenging to get some sort of understanding. Don't talk about agreement, but talk about understanding first. So sometimes when we have something concrete to see, an object, a model, it somehow puts different people kind of like on the same side of the table, looking at confronting a common object. They're not confronting one another, but confronting a common object. And that sort of like builds a relationship, changes the discussion a little bit, you know. And so digital twins, you know, small form, bigger, mega form, are beginning to sort of like foster this kind of dialogue more and more.
Interesting start. So I guess the need to innovate that brings about adoption of new technologies, creation of new technologies, and so on. So how did geospatial technology start to gain traction in the built environment industry? Was there a eureka moment that made architects or engineers realize that technology would have a great impact on their work?
I think I look at Singapore when I first came in, that was because WCS. And we were already, that time, I was leading a team in Malaysia to regenerate Putrajaya and Cyberjaya. That was a project, and that started because of Masdar again. So we know the history of 2007 NA. I think Singapore took the opportunity because early on we realized technology is basically, if not the panacea, is a great solution to improve the productivity of the construction industry globally as a whole. Singapore today is an incubator in the construction industry, unlike many other countries and many other cities. So if you look at it's basically a flow starting from innovation and then innovation, we have something called incubation before it gets into construction. And that is basically, it was not a eureka moment, but we took the opportunity when we looked into the numbers that started coming out in 2008, 2009. I think the government took the opportunity to finding a problem, that here is a problem, the global problem, and Singapore, because of our leadership in technology, could take the advantage and become the incubation center for all the companies and suppliers. So that's how basically I believe that it all happened. And we know now that how many companies are actually based here, for example. When we talk about smart cities, we think about Singapore, right? So I think that's what my perspective would be, how I look at what happened.
Yeah, I can chip in, and that's very true. I think that very clear commitment and investment from the government of Singapore is globally recognized, and it's gained a lot of traction, a lot of good faith and trust, right, in the way Singapore is positioned. Again, it's not just, I really want to underscore what Saibal is saying, it's not just a technology, it's the ecosystem, right? That facilitate the business, the sort of rule of law, the integrity of contracts, etc., etc. I think that's important to recognize that. And if we can take tools as simply an enabler, and the more we can open that sharing of those tools and concepts, the more successful it will be. However, coming back to our building industry or the built environment, I have to say, relative to some other sectors, we are lagging behind. And that's something that we all hope that we can truly expedite and catch up, right, to the other industries, the manufacturing and the IT. We need to really take a very serious look at the accelerating the progress and capitalizing on all those wonderful technology and investment to address, as what Leslie also mentioned in the beginning, the life cycle. We will not get the effect if we simply tackle the process at an ad hoc or stopgap basis. It has to be a connected process. Otherwise, again, it will delay this effectiveness of the uptake of the technology.
Yeah, I think there's a lot of opportunity for more people to adopt geospatial methods. There's a lot. The plus side is we have seen some who are already who have already adopted them. They're gradually transforming their own methods. So the eureka moment we've seen among those early adopters is not what to do, but it's, oh, I see, here's how I do it. Very simple thing like when they want to plan a township, they realize it's a complex interplay of terrain, major concentrations of population, major transportation nodes, and it's not that they don't have data. It's about how do I bring it together. The answers have always been there, actually, quite frankly. It's just that they've not yet had a chance to be taught and shown. But once they're given a little bit of coaching and training with the correct tools, they're pretty self-sufficient. I know Prof. Lam and Saibal have spent many years in GIS. Prof. Lam, before coming back to Singapore, he was in the US already doing a lot of GIS, but I guess he can see that there's so many more generations to want to train, right, and put it together. Well, Esri and SDE, School of Design and Environment, have a MOU to create good models and examples, methodologies to train people faster, to equip them, for more self-directed learning. We only have a limited number of time in a week, in a year to train people. So the most lasting effect is really self-directed learning, but we got to get them started somehow. Right? So it's simple harmonizing of data, asking the right questions, visualizing, and then iterating it. Yeah. Oh, I also would like to I heard this quote from our chief planner, Huang Yuning, recently, who said, modeling a city is not as simple as modeling a car or factory, because a city is a live thing. You do something, it will respond instantly. Whereas in a factory, you want that reliable input, reliable output. So it's quite a different, but exciting ballgame altogether.
Indeed.
Thanks, Leslie. So as Professor Lam mentioned, we're actually lagging behind this industry, and what Leslie mentioned is that the adoption of all these technologies basically started off as an afterthought. So what do you think are the main factors that can drive the adoption of geospatial technology in this sector, and maybe taking into account as well the current pandemic that we are in? How can one be able to get the adoption of geospatial technology to improve in this industry, in this sector?
Well, let me make a start, perhaps. Again, it goes back to this seamless connections, right, of all the toolkits to facilitate that end-to-end process, from the macro planning all the way down to buildings. And right now, they are fragmented. You have the GIS basically dealing with the larger planning environment, and then you have the BIM that's dealing with the building level kind of resolution. My own kind of dream is those two should really become much more connected, much more seamless. But I think one important ingredient, and I've been sharing about this quite a lot, is to really change our whole economic mindset from a two-dimensional to a three-dimensional. Architects are good at illustrating, fly-through, and 3D modeling, and very impressive. But when it comes to quantifying, right, the performance of those artifacts in terms of air quality, it's not embedded in a natural way. And all the way down to now with the COVID, now everybody is scrambling to understand ventilation, right? And ventilation is by definition a three-dimensional entity. And if nothing else, you hear all those horrendous stories coming out of India where there's not enough oxygen. Well, it's the same thing in buildings. Even under normal circumstances, we need to have good air to breathe, right? Whether it's pandemic or non-pandemic. It's just preventive kind of practices. But right now, that is not there, right? We're still quantifying using the technology to sell dollar per square foot or dollar per square meter, right? Real estate. And the difference in price is location, 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 right? So we need to change that, I think, to drive this whole further uptake. To extract the maximum value of this three-dimensional understanding and visualization is to provide this performance quantification along with it, whether it's in ventilation, whether it is in, carbon. That's another big thing we're talking about, right? Embodied carbon, what goes into making our buildings, what are the volumes of materials, et cetera, et cetera. I think the GIS and coupling with BIM can really address and further promote that kind of adoption in the future.
Yeah, Prof, I think I always say it's not about integration of GIS and BIM. We have been talking about it for a number of years now. What actually has to happen is technology gone so advanced that we should have a coexistence. We should basically get it so seamless that we don't have, and I remember one of the architecture firms say, we hate it when we have one PC and then software A, software B, software C. Can we have one software, right? Like for example, and I seamlessly navigate through, right? So it all happens. So this is where we are in, and I believe we are in the point where we could actually jump into the next sector. It's not about integrating GIS with BIM. It's about being safe. And we started that. I mean, my personal research in this area started in 2011, 2012, when I started coding at night. I mean, after work, right? And since 2015, we basically built the software, which basically is basically we're looking, look. Unity is one and Cesium in one. They don't go along with each other. So we need to write another own proprietary data format so that these two become one. And then started a journey. Instead of starting, of course, we started a company by saying, can we go around, do pilot 8 to 10 cities around the world, Latin America, Europe? And I wanted to know what is so different between different countries. So then come back to Singapore. So we are actually, what I say, at the moment, we think the issue is the dynamics of the built environment is so complex, and there's so many influencer and opinion and vested interests in different places. It is taking for time to make the simple thing as one. I agreed that modeling a city is far more complicated than modeling an automotive supply value chain or something else. But yet, I think we have enough understanding now so that we could actually create the technology to move everything into safe. So the drive is, no, it's not about integrating GIS with BIM. It should be what do you call as a seamless, which is called coexistence. And that's where the built environment, or I call it digital twins, as we call them, okay? It's not a new concept. I started my first job 82, and my first job was CAD. So that was the what do you call it, digital twin anyway. But we have come across in a many different ways where we can add economics, sociology, science, technology, architecture into one piece where we could actually do the simulation in a way, not like simulation as a gaming tool, but as in real life. And that's probably is the most exciting thing. And that means you need to do these and practice in an environment which acts as an incubator. And that's what makes, again, coming back to my old point, Singapore perhaps is the best place to give us that ecosystem to try out these things.
Yeah, and I guess we're quite nearby together. You know, the land constraints lets us, closer proximity. Okay, now temporarily there's some movement control, but it'll pass. So you're right. No, I think BIM and GIS for a long while, or CAD and GIS for a long while, has already been able to integrate. Over the last several years, computing power has caught up a lot to be able to ingest more volumes of data and more diverse types of data together. And so much so, I think, once again, we have crossed another cusp to be able to support different types of users in each of the 4 life cycle stages to extract from the digital twin what they need. So, the planner needs something from the digital twin, which is similar to what the construction companies need, but the construction companies are going to need something else as well. So I think the technology today has advanced to such a stage that it can serve the different profiles a little bit better than previously, because each one's definition of performance, is a great reminder by Prof. Lam. Each one's definition of performance at different stages is different. The planner, yes, maximize space. The construction company, P&L and wastage and safety. The users, they want a better experience. And what does that mean? Cooler, the different kinds of measures. So now I think we are. It's quite exciting to be able to adapt technology and knowledge and output to serve these sorts of different profiles and.
Yeah, the feeding in to there's some background. I think it's really true that at the end of the day, I should clarify, it's not so much, as Saibal said, about the tools themselves. They're just tools, I always say. It's always about the process and how people work together and what are the input and the output. So the output are defined, and we like to see more of the output being codified in sort of standards and so that it drives the industry, and it's not just individual owners or developers want to do it. In order to do scaling up, we really need to convert many of this knowledge into codes and standards. But the other big challenge is the data input. To me, right now, the data input in terms of the physical entities, the dimensions, the heights, and the volumes are all good. It's self-evident. You don't need to do too much about it. But it's all the other stuff that go into the buildings and the landscape and so on and so forth to get the kind of data that is accurate and that truly reflect the scientific rigor that people do in the labs, those of us who do things in the labs, how to translate that into everyday, right? So that the end user, the designer can actually extract the right data, feed it into the model and get the right predicted performance. I think that data input is still, again, a big challenge to, first of all, have the data and then to be able to access it readily. So most of the time, that's where when we do modeling, we get stuck. Where do we get the carbon content of that piece of plywood, for example, or what is the VOC in the glue? When we were doing ceiling fans, what is the profile of the fan that can generate certain pattern of movement or air movement? Fans are fans, they're very different depending on how you design them. And of course, how much they cost as well, right? So there are all this data that I think would be another important focus in promoting and expanding the use of any kind of design support tools.
Yeah, I think, Prof, that's where the frustration, I would say, is if you are in a, I again, give an example. There was some joke where say that if you die as a physicist, okay, you will basically in the next life, okay, if you die as a good man, the God will send you back as a physicist because it's an easy job. If you not very good, then as an economist, But if you die as a criminal, you will come back as a sociologist because you cannot model anything, right? So the task is very different. We have that as a problem when we're modeling the cities. It's very easy to do a building. I mean, architect's life is much more easier, as I say. But a planner's life, okay, though they are not the most celebrated people on this earth, but the planner's life is far more difficult. And as I said, I give an example. So I go to an artist and say, what if you could drag and drop your design, whatever you're doing, either in, let's say, in Rhino, into a GIS software, and immediately tells you what's the cash flow for the next 10 years, how can you improve it, what's the sustainability measure, where would you basically pay? But the problem is, where is the data, as you said? We go into cities, the accuracy of the data, the validity of data, and you can always question. So as a result, we are still stuck in a way where we could actually do things in a small area, which is a small development, maybe 4 or 5 buildings or a single building. But the moment you get into a city level, it is a challenge because you don't know where the data is coming from and who is updating it. And that's where basically the issue is. I believe what we need to do is look at the automobile industry, right from the OEM guy and to the line, first tier, second tier, third tier, fourth tier, they're all in sync with each other. Okay. And whereas in our industry, in the construction industry, that's the biggest problem. The architect, the local authority, the central federal authority, they have their own rule. Then you have basically other legal, regulatory. There's so many bodies with so many interests. We never actually have a common data that created that everything is updated when everything else is changed. And that, how to change it, only probably Singapore is the best place to basically change it. Maybe similar countries, but if you look at a bigger countries like China, India, and other places, that will take a major effort and long time and leadership to get into that level. So that's the challenge that I see in the data input.
Yeah, I think you're right. And I think I also heard Prof. Lam mention that, well, we start somewhere to try and tackle that. We start with some standards. Like, for example, if we can have a widely, not universally, but widely accepted measure of carbon performance, for example. I'm sorry if I'm mincing, chewing up your words, but it's just a commonly understood small set of measures. Then they get the ball going. Like you mentioned, Saibal, then the guys in stage 1 and stage 4, they can gradually get aligned in spiral after spiral after spiral.
Yeah, I think you're right. I think the challenge is not about understanding the interrelationship between different processes and nodes and other. That's not a challenge. We have enough intellectuals and experienced people in the world and in Singapore. But the challenge is the model to work. You need data coming in all the time. How to get those data in, and how, even if you use artificial intelligence, machine learning, you really need the data to be right. And I think that's what should be the next challenge that we should actually tackle. And I know Singapore has a great initiative, the smart city, what we call city as a service model, right? And that's where I drew personally the inspiration in, when it started, and we are actually doing it. But this has to go in a way where more and more different kind of data, social data, behavioral data, you're talking instrumented data, other text data, all these has to come in. And then probably it will be an ideal situation where the processes that we know how they interact and actually the people could actually practice. So that's basically could be the next step of where we are today.
Yeah.
So I guess I think everyone agrees that data is the key in driving this adoption in the use of geospatial in the built environment. Moving on to the next question, talking about, someone mentioned about architect. Just to have an idea, how does one, given that built environment sector is very broad, but how does one use this geospatial technology in his line of work? Taking, for example, as an architect.
Yeah, let me try and address it. Again, projecting what are the value adding sort of aspirations moving forward to drive the uptake of technology is to go beyond the current sort of well-prescribed deliverables, right? Give me the GFA, pass the URA, pass the fire code, and all that. But really look at from the occupant perspective, the needs of the occupant at point of design and anticipated future scenarios. Again, this surfaced dramatically because of COVID, right? Everybody is now asking, how can I make my office flexible? A very simple question. And the point now, the lesson learned is that as we move forward, for both the new build as well as huge stock of existing buildings that need to be addressed, as Leslie was pointing to, we really need to take a very serious look at that long-term strategy from the occupant perspective, as the use continue to change. I think the architects are trained actually to do that, because that's their value add, that's their primary professional, input. So we just need to facilitate. We, as in the clients, the owners, and the regulators, to facilitate this sort of approach, that when you build this model, whether it's in GIS, BIM, and combinations thereof, it's about not just checking off the boxes and getting the TOP, but it is a continuous performance. As built, number one. Even that, I think so often we take it for granted. We say it's as built, but is it really as built? So often we don't know. Then to be able to then measure the changes that will inevitably come. I mean, it's just life, So often buildings, even as they are built, when they open, they already change. Because the client wake up one day and thought of something else, right? So that is just a fact of life. And therefore, building in this sort of limits of performance, or limits of acceptability, we call it in my concept of total building performance and diagnostics, is that we built in certain level of flexibility, but it doesn't mean it's endless flexibility. Let's not overpromise. There's no such thing as infinite flexibility. There will always be some boundary, but at least we create that boundary so that as things change, we are able to very quickly analyze what are the implications. Hopefully we get it right. But then even so, after implementation, we continue to get data. Dynamic real-time data is what is needed so that we can preemptively, address the problem and not do what we are typically currently doing, using the crisis management mode, right? When there's a crisis, we jump at it. But when things go back to normal, we take it all for granted again. And I think, again, the COVID has given us many lessons in this regard, Human nature, that's just very, this is happening all the time. Thank you.
Yeah, thank you. I mean, this is one area that how do we harness data, and how do we build new data from the old data, and then how do we, in our schema, how do we basically store, use, analyze? That probably will give us far more insight. And again, as I said, that initially I thought the AI and machine learning probably is a little bit of hype, too early, but more and more we work, we realize that actually it can take away, it can really jump productivity. There is, as one example I will give, there is a tool. Now suddenly I saw, I got an email from World Bank, and they say, we have an energy modeling tool called Edge. And I said, World Bank energy modeling tool? You know what they're talking about, right? I spent like years in making huge spreadsheets to get one building in green. So yeah, and it works. Let me tell you, if you use a DOE's tool on that a particular building, and in Philippines, new building, and if you use their tool, which is almost free, okay, the plus minus is only 5% if you look at your energy bill. And that is what basically kicked me, that this is one area where you could actually, because all you need in a typical building physics, as you say, right? For example, as long as you know the exact location of the building, the orientation of the building, the weather data is there, people data is there, how they're moving, R value, U value, residential, land use, everything, it actually draws in with a similar building in Philippines and Manila, for all places, and say, your energy bill roughly is this much. And it's first price. So that's another area that I'm looking at, where architects, as you say, that you can drag and drop a building, and you can actually go and say, okay, this is going to be my cash flow for the next 10 years. So I can actually don't have to, I mean, in general, saying that we don't need a valuer, probably. Architect is responsible for the overall life cycle performance of the entire building that he's selling and proposing it to his client or her client. That could be an amazing thing to do, basically, because the data is available, the tools are available. I have my imagination, and I believe that architects are and planners are the forefront of imagination. So they could actually get the imagination to work and actually get more productivity out of the basically whole thing.
Yeah,
Okay,
so I think there's a great opportunity there, because if that's one good example of how something has not been made not rigid but systematic. Structured inputs, intentionally structured and designed, so it's made systematic. And architects are also very creative and artistic people. So we have the ability to be able to take this systematic metrics and inputs and display it. Because once we display it in a model, the audience who's not trained like an architect, but intuitively they'll be able to understand and support it. And if it shows that your energy consumption will be lower, your temperature will be lower, or different new measures of users' experience, of the asset can be defined and visualized and communicated. It fosters a far greater understanding, so that when new designs are proposed, it hits a more riper soil, riper ground. So I think there's a lot of opportunity for meshing these methods together.
Thank you. We'll move on to one last question, touching on capacity building, career path development. So with this trend, how does it help to evolve careers in the built environment sector, and what are the upskilling opportunities that are available?
I think that's probably one of the most important, the last but not the least, as you say, question for me. If you look at talent, is probably the most important thing. I remember when I first joined my old company in HP, they say, you're not an engineer, we only hire Imagineers. Okay, we don't leave imagination to someone else. Okay, you're an engineer, you're an imagination, and that requires a different kind of talent skill. When we sell our software, one of the biggest challenges is that, Saibal, when you go back, we cannot work. Nothing works in your software. When you come back, are you dodging? Are you a dodgy kind of a character? I said, look, I have sold a software, but not an imagination. Planner must have that imagination to sit in front of a model and say, what do you want to test, right? What do you want to find? So the talent is, and now I personally, I don't want to be criticizing a bunch of organizations and institutions here, but here is a problem that we have different within the ecosystem. The level of imagination and execution capacity are completely different. And that is creating a huge problem with the municipalities, the government authorities, the architects, the planners, the construction companies, the developers. They all have their own, everybody has vested interest, but I think the level of understanding of the built environment and where I am and where I want to go and how to go there, that understanding is completely fragmented and different. And that's what I think this is something that we need to address.
Yeah, agree. And it really then comes down to the foundational education, I think. That's going to be a really important shift. Because traditionally, what sort of created what Saibal said is because of the conventional siloed educational sort of method that we basically train, right, architects in their profession, we train engineers in their profession, we train planners in their profession, and send them out to do their job. But life has changed dramatically. So in order to address all these emerging challenges and problems that are clearly cross-disciplinary, that our education system must change. And I'm happy to say we at NUS have done that or are continuing to do that. As you know, our School of Design and Environment and the Faculty of Engineering has just rolled out a new common curriculum where the freshmen, the first year student coming in as of August, will have to take a suite of common modules that are going to be necessary to address those complex challenges of the future. So all of them will need to learn about design, for example, regardless of whether you're an architect or an engineer, right? All of them will have digital literacy, right? To understand, not necessarily to do programming per se, but actually understand data and how to analyze and how to spot, right? Good data versus bad data. Those kind of will be rolled out as of August. Now, we will take a little while to see the impact of that in industry, but we need to make a start. And so we're doing that. Then even further in the future, I personally feel that there's a lot of scope to even cross beyond the sort of architecture engineering into the health science, into the social sciences, and the medical situation. And every time I compare the medical folks doing research and the way we do research in the pseudo kind of way, in the built environment, trying to do social study, I think there's a lot we can learn, right, from those other domains that can really get a very rigorous approach to getting the right data and at the right time in the right place and feedback in the knowledge loop in the design. So that's something that we can certainly build on in the future. And education will play a basic, fundamental role in that.
Thank you, Prof. Lam. Probably one last input from Leslie before we move on to Q&A.
Yeah, I do agree that general education can work, have a lot of impact. When my son was secondary 2, I flipped open page 1 of his geography textbook, and embedded in geography is it's the science of observing the world, the Earth. And the very first example they picked was GPS. So I think a step back and look at it. GPS in this age, I just realized that location intelligence has become a way of life, or the recognition of it has become pretty high in the subconscious, let's say, but also which influences the conscious, the part of subconscious that influences the conscious a great deal. It's become a way of life. So the fundamentals, if they are taught broadly enough to the mass audience, like simple things like map projection, cartography, common types of data, what are the typical applications, that raises the baseline, so much so that then the experts, the specialists, they see a well-informed audience, and that's when the paradigms can change. I think paradigms can change. When paradigms change, we're going, the experts are going to be able to prioritize, where else they need to be innovative about, and from design methodologies, from testing, from IoTs, they'll be able to choose more selectively, and yeah. So I'm pretty optimistic. Even in secondary schools now, there are programs that teach secondary school students how to use GIS to augment their learning. So the desire is there. It's really great.
I have one small input for Professor Lam, because this is one area, because this is where our pain is, talent, right? We have a policy in our company that even if you're a secretary, you need to know how to program, because that to me is the only way to write your imagination onto a paper in a way that people can understand as the input, output, and a process. So, okay, so I was probably too ambitious. So now it's like, at least you knew how to do a flowchart, right? Good.
Yes.
Here is the problem. I hire people and they say, oh, I'm digital. And I say, that's not enough. The fact that you are better digitally or better digital if you know how to program. So what I wanted to basically in the faculty, because I've said that the programming is the first step to understand what data I need, what is my input, what is the output, and what is the format. If you don't know how to program and you call yourself digital, it is not going to work.
Yes.
That's what the input I wanted to give.
Agree. Again, it's really the whole thought process of mapping out the problem statement and then what the output is. What we don't want to convey the wrong thing is that programming is just another person clicking away, and writing code. And that's not what it's about. We all know that. Because now there are so fascinating tools that you can do programming. My grandson, 8 years old, he's programming. But the tools he used to do programming is not writing lines of codes, right? It's all very graphically driven, but it makes him think about the problem statement and doing the process. You're absolutely right. I think that's what we want to convey. Otherwise, the students might misunderstood and say, no, you're just making me do donkey work, No, it's not donkey work.
No, that's how to express yourself. In a way that you and others understand, and that's how the great programmers and great entrepreneurs in the Silicon Valley, because for the love for looking at a problem and finding a solution programmatically.
Yes. Yeah, I personally was exposed to that in my architectural program at Nottingham University. In the 4th year, the professor said, I'm going to set 2 weeks, write a program in BASIC. And that got me caught into this whole interest myself.
Fantastic.
Okay, with that, let's move on to Q&A. We're going to open the floor to some questions from the audience. So we have one question here. To counter the flooding issue in Singapore, what solutions should we be aiming for? More drainage or water absorption facilities? Any interesting overseas case studies? Anyone would like to?
Could you repeat that? I couldn't hear. If you could repeat that.
Yeah. So to counter the flooding issue in Singapore, what solutions should we be aiming for? Whether is it water drainage or water absorption facilities, and whether there are any interesting overseas case studies.
Well, I think flooding and traffic are the first two things people ask me when I go to sell. Can you see flooding? And second is, and it's interesting, a lot of universities in a lot of countries, when you go to Philippines and Indonesia, they get a lot of aid to handle this called flooding. But why there's still a gap? Okay. And again, I don't want to go to what I discussed. I believe the AI and machine learning can actually do a better job and easier job for people to do rather than going into CFD that we used to do before, right? So we would basically do a CFD modeling. I have a rain data, I have a precipitation data, I have every other data. And then before rain or after rain, at the time of raining, I know this is my terrain, okay? And how the because flooding is happening not because you're raining here, but they're raining elsewhere too, right? So you need to really do a very massive CFD calculation to come out. And that time of the geospatial technology is not available, and people in the university, that's what they're not practicing. They have some primitive thing, but very academic that they want to do. So I believe that a lot of students and professors in these countries and outside, they're not able to. If you go to Germany, if you go to Austria, if you go to even in Holland, they have amazing tools that they work with, right? Combining everything. So one of the idea for this part of the world where they do not have that much of talent capacity in terms of money and talent and everything else, is the adoption of newer technologies where you can use the model to train the model and basically commit to the accuracy much more cheaper and easier to use these to AI and that's what is happening today around the world, that people are using AI and machine learning to predict flooding and traffic both, and it is very, very accurate, let me tell you.
Well, I guess I can only share some observations of from what I see how PUB has the different programs they've adopted over the last decade or so. I think there was an article in the Straits Times 2 weeks ago talking about the total surface area of flash floods have reduced from 100 over 1,000 down to just a fraction, or less than a tenth of 5%. We got to ask, how did they measure that? Okay, that's interesting, but they won't dare put out a statement like that if they did not have a way to measure it. Right? It's not a perfect model, but there's a consistent model in which they could do so. And at the same time, flooding in any landscape, any city, I think is a moving target. You got we're being built up every so now and then. Brownfield sites next to built up area and all that, and construction is happening all of the time. Canals are being widened at different cycles and stages, so it's a moving target. But first and foremost, they began more than 10 years ago with a model of the island, and it over the years it got more and more high fidelity. They started somewhere, so because they did start somewhere, I think it's a complex equation of rainfall within a period of time, built up area, catchment areas. They will know, all this kind of metric. They've got something somewhere. So it's a multifaceted and ongoing sort of like a continuous analysis and feedback kind of a program that they have. I don't know whether that answer your question, but I
want to add there. I mean, since it's a discussion, I believe flooding is a much easier problem to solve than traffic. Traffic is in our software, we don't do traffic. Why? I'm very scared because of behavioral modeling and all kind of stuff. MIT do it, right? For me. But flooding is quite deterministic, right? As far if you have the complete terrain model, you have all the past data from meteorological data and other data, you have the terrain, you know the height and the terrain, the built environment, you could actually generate a capacity demand from there, that stormwater, basically modeling the stormwater requirement. The issue is, what I find is it is prohibitively expensive sometimes for the taxpayer money to get the flood water out. So for example, that's what my personal experience. But in general, I think the flooding, because we did flood modeling a long time ago, 4 or 5 years ago. And I think it was relatively easier than the traffic. I'm looking at a difficulty. Professor, Papa, this is a very academic area. A lot of people are doing it. You probably are the best judge for that. I just gave my opinion that that flood can be handled.
I think it's worthwhile to remember. I always want to go back to the root cause of why we are confronted with this kind of issues, right? It's not as though there's no investment. Singapore has invested continuously on widening the drains, making more and more, drainage systems, which resulted in improvement, obviously. But the problem is that the conditions have changed so dramatically because of climate change. I think we need to recognize that and deal with it. It's always, the problem is a combination of what they call the perfect storm, right? Where it rains like crazy and it's a high tide. And that's, for that instant, you get your problem of flooding. It's not a persistent thing, but in that moment, everybody is inconvenienced. So the question is, how can we deal with that? How far can we design, right? And how much money can we put into to mitigate that risk? So this is the question that will continue to challenge us. But coming back to getting data, getting good validated models would help to some extent to at least put some options on the table to recognize that. But to me, if we don't deal with the root cause, there's no end to it. This problem will become more and more intense, and land will be lost, will be flooded. And that's the projection, by the way, right? Sinking cities and so on and so forth. So this is something that we need to spend some time and resource to deal with the root cause. Yeah. Thanks.
I think the flooding in the urban areas are different than flooding in a non-urban area. If you get into some of the flooding report that you got the LiDAR generated, for example, right? And I think you're right, which I actually missed, is actually the weather pattern has changed so much and so unpredictable. As a financial modeling, then you do, and they say, this is the capacity, how much I can go and spend and how much it will be utilized. So that's an issue at the moment. Yeah. So how to find the optimum that we can, okay, once in a while there will be a flash flood and we will lose something, but it will not be an occasional thing. So then this is the design. Yeah. I get it. Thank you, Prof.
Okay, thanks. Okay, perhaps one last question. Leslie's positioning regarding the CD being a live asset to model and manage, and then also Professor Lam commented on it as well. What are your thoughts regarding the need for real-time understanding or monitoring of the city, and what are the opportunities that that you can get the most value out of?
Yeah, I think it starts with similar to what Prof said, go to the root cause. If we begin with what is the objective in mind, what is the end goal we're trying to achieve? Frame the problem. Once we frame the problem, is it reduce wastage from households? Is it reduce kilometers traveled? Whatever that is. Then it depends. Then that will inform what is the definition of real time. Sometimes to some people, real time is every second. Other situation is once a day or once an hour. I recall that beginning, I think almost 5 years ago, URA with a few other agencies shared data on a continuous stream. Some people give them once a week, some people give them once a month, some people give them one every day, and they had a city dashboard, energy consumed, energy produced, and they had some other algorithms, and they projected it ahead of time to see whether the current stage rate of construction of my waste incinerators, can I catch up with demand? So things like that, right? Now that is about very waste management. If we can define the objective, then we'll know what kind of real-time data and static data to intermarry with.
Yes, if I could also add another interesting, funny example. When this whole data collection started in the building industry, buildings, people were boasting, oh, I have data at milliseconds or 1 second. And I said, what's the point? Your mechanical system can only react hourly at best. So why are you collecting, 3,600 data points for? So I think it has to go back to that pragmatic understanding of systems and its performance and its operation, so that the data collection can really be useful and codify and process to affect the system themselves, so that then it makes sense. And people, otherwise the negative sort of impact of us convincing the client to spend money to collect data and this sort of thing happens, it just erodes their confidence or their sense, right? They say, I'm wasting money collecting all this data and they can't be used, or most of the time they are corrupted or whatever. That has a negative impact on the perception of investing in data collection. Let's do it right, do it well, for purpose, and then I think the results will speak for themselves.
Yeah. So to Anu, we're not saying that real-time information is no good. We're just simply saying that there are different units, different kind of frequencies.
Right.
I think that one short answer for me would be some examples. We were comparing Melbourne and Vienna, right? So I without getting into detail, basically one city will have 1,500 data sets, but they're utilizing only 10-15% of it. The other has only 600, but utilizing 100% of it. So one of the key thing about it, when you do a data thing, you need to really know what exactly, and that's what I say, programmatic thinking. Singapore is a small place. It was much more easy to put together a team, get in the room, and then say, this is the process. And the process will tell what data sets you require. In many cities, we are actually blindly getting all the data, and it is a huge list. And it costs a lot to maintain, acquire, and manage. And then end of the day, we will look at the model and saying, I'm only using 15 to 20% of it. So that's one way of achieving to, over a period of time, you will know what is unuseful data, what is useful data. But I think for Singapore, I think because we have more experience and we have, and of course, we are more sophisticated in user technology, I believe that could be done very easily. And actually, I'm surprised why, because 2015, if I go back, and all the whole idea was to build a city as a service model. Now we have GeoWorks and others and SLA. We should actually take this forward to set an example how this whole thing works really as smoothly as possible, and then use it in different countries. I mean, that's where the private organization like us, we do. We learn from this whole experience doing it here, and then we try to basically do it elsewhere. And I think it will be a good experience, especially when we compare areas like, let's say, Norway. It's one city we work, it's only 50,000 population. It's a city, right? Only, and they want to increase it to 100,000 over the next 10 to 15 years. That small municipality has a CIO, CTO, and a CDO. I'm talking about Chief Digital Officer. Where do you see this kind of model in cities elsewhere in Asia and other places? So again, it's the process, people, and technology and data all have to work together. And I think that's where basically the challenge will be how to synchronize them and make it work together.
Yeah. Let me share an account. A friend of mine, tongue in cheek, mentioned to me some time back, say, people say data is the new oil. So I said, yeah, I kind of agree, but, crude data is like crude oil can be quite toxic. So we've got to refine it. So it's really, what people, I believe, desire is insight, information and insight.
Yep.
Okay. So we've kind of overrun on time. So I would like to say a big thanks to Professor Lam, Leslie, and Saibal for giving us these great insights into this industry. And with that, I'd like to mention also, we do have some resources that you can look up in geospatial.sg website. And we also have the 3D Singapore Sandbox over at GeoWorks. Do engage with Esri and find out how you can actually check out some of their tools together with data from the government, from SLA, over at their 3D Singapore Sandbox workstation. And then also we're going to have the Singapore Geospatial Festival coming up in September. Do look out for announcements, and we hope to see a lot more participation this year around. Hopefully that this pandemic recedes in time for us to actually have some form of physical or hybrid event rather than just being online. Okay, with that, I'd like to thank everyone for joining us in this virtual Fireside Chat. Thank you very much, and thank you, everyone.
Thank you.
Thank you.
Thanks.
Bye-bye.
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 Bye.